All right. Hi, I'm Baran, and I'm with Veer, part of Skillshine 25. And today we're going to take a tour around Jenkins Electricals with Mr. Jenkins himself. So without further ado, let's go ahead and begin.
All right, so the building that we're in right now, and if you bring the camera around this way, you'll see is the repair building. And this company started as a repair company when textile mills in this region switched over to electric motors in 1907. A lot of what we do here is still very similar to what we did 118 years ago, even as the world has kind of evolved technically around it. Electric motors, I believe, still 3/5 of the power generated, I think, flows through electric motors.
Wow.
And that's only going to increase as transportation gets electrified and other things. So it's an interesting business to be part of. This bay is the machining bay, and so the equipment on either side is manual lathes. Manual lathes are much better for repair because when you're bringing in one component that needs to be reworked, it's not efficient to have to write a program on a CNC machine. Also, these manual machines are very large capacity. This lathe, for instance, can turn a 35-foot long piece of steel.
Wow.
Yep.
Yeah, so you mentioned it's not as efficient yet. Do you think there's a point where it's manual work like this is going to be irrelevant?
No, I don't, because the advantage of computer controlled is that you can repeat the same thing over and over and over again very efficiently. So in a computer numerical controlled or CNC machine, you can put a block of steel or whatever metal you're using into it. It'll make the part, put another block, it'll make the exact same part, and so on and so forth. In the repair world, you tend to be doing one part for one piece of equipment.
Yeah.
So the flexibility of manual, I think, is going to make it last.
And of course, it won't be the same for every repair too, right?
Right, exactly. Yeah, and one of the neat things about this business is even though we're 118 years old, you still see something new just about every day.
Really?
Come in, yeah.
Yeah, look at all this stuff here.
One of the kind of market areas that we have for the repair business is hydroelectric. So there's I think by volume, more hydroelectric dams in the southeastern U.S. than there are in other parts of the country. The original purpose of a lot of those dams was to power textile mills. That industry has largely moved out of the U.S. And now it fits into the renewable mix with wind and solar, and utility companies are doing a good bit of investment. This is a horizontal generator out of a Duke Energy plant in the North Carolina mountains. One of the interesting things about the hydro business right now, particularly as it relates to the North Carolina mountains, is this generator was flooded during Hurricane Helene. And so we're doing a mechanical tear down and recondition to determine if it needs to be just mechanically repaired or if we're also going to have to do the rewind.
Yeah, is that what this bit of rust here is from?
Yeah, these units spent several weeks underwater.
Wow.
After Helene. Yeah, and then we've got several projects right now that are cleaning, drying, testing, repairing as necessary of hydro plants in the North Carolina mountains.
Awesome.
In addition to machining, we do a lot of mechanical repair, which tends to be assembly and disassembly. In this particular instance, this is some kind of cylinder out of a manufacturing process that we're balancing. So essentially what we're doing is spinning the unit to determine where the out of balance is, and then adding weight on the opposite side to make sure everything spins in a balanced way. Out of balance creates vibration, wears out mechanical components. As you can see, if you kind of pan around, there's all different shapes and sizes of electric motors. The vast majority come out of manufacturing processes, and this bay is, again, the mechanical assembly and disassembly. So it's checking the mechanical fits, replacing the bearings, and this is a very good starting point for somebody. You mentioned internships before. Somebody who's mechanically inclined, likes to take stuff apart, likes to work on their car, likes to work on their bike, whatever. It's a very good starting point to learn the business. This is the winding bay where we're rewinding electric motors and generators. In this case, you can see that it's got new copper windings.
Right.
The basic rewind process is, if you look at this unit here, it's taking the windings out of the motor frame, building or winding new coils to go into it, and then replacing them. These yellow units are backup generators. These are used in hospitals, data centers, anywhere where you need critical kind of power continuity, where if the power goes out, you have to have a supply to turn on that's not reliant on the grid.
It looks like it came out like a Transformers movie or something. It's huge.
Yeah, you know, the repair world tends to be larger and larger equipment over time. A lot of the world has gotten to anything small and affordable gets replaced rather than repaired.
Right.
And you know, and one of our goals is to make sure that the work that we've got our employees working on is valuable work where they can also make good money in
Right,
addition
yeah.
to the company. And part of that means you're working on large, expensive equipment.
Yeah.
These are, you know, two additional good examples of winding in process where there's insulation and copper windings in the motors. This is a GE water-cooled motor, and if you look down into the center of it, you'll see where the winders have replaced all the coils, and then these are the power leads coming out of the motor. There's definitely an art to a lot of what we do.
Yeah.
That, you know, skilled trades doesn't just mean nuts and bolts and hammers and
Yeah.
power tools, but a lot of what we do takes, you know, technical aptitude, but also artistry.
It's huge, bro.
In addition to electric motors, we also do transformer rewinds. In the case of the transformer, it tends to be remanufacturing based on the design of the transformer that failed. There's a lot of opportunity in building replacement transformers as the grid evolves. New, you know, power sources like wind and solar require additional transformers. In a growing region like Charlotte, the utilities having to increase capacity. So there's a lot of opportunity in the transformer business. And it's something that we've done since the 1950s.
Wow.
Let's go into the systems lab. So in this part of the business, we build control and test systems. This is from a kind of technical perspective, wiring diagrams. All these are designed using AutoCAD. A program on the control side that's a PLC program using a PLC instead of a PC. And then in a product like this one, a PLC program, a C# or C++ user interface, and typically these systems are also remotely accessible, so there'll be a kind of remote login capability. These systems are used for testing electric motors, either in other electric motor repair shops or in kind of end-of-line testing in manufacturing facilities. We've actually got a project where we're going to be building electric motor test systems that go into submarine manufacturing facilities. Yeah, so one of the neat things about being in a business that supports other industry is we do get to understand how a lot of different businesses work.
Right.
So just similar to what you guys are doing with Skillshine, where you're understanding what jobs are out there. A business like this gets insight into a lot of what other companies are doing.
As you can see, you've really expanded too, right, from where you first started.
Yeah.
So, really impressive.
Yeah.
Has this been the main location the entire time?
So the company started out on 5th Street, right off of Tryon. So this was 1907. 5th Street was a dirt road at that point, and they were bringing motors in on horse-drawn carriages, or wagons.
Wow.
It then moved down to Trade and Graham Street, kind of behind the Knights Stadium, and then down to a location in the 1920s that's behind the Panthers Stadium.
Wow.
After my grandfather took over the company in the 60s, he bought this property that was formerly a drive-in movie theater and built this building in 1976. So, or actually, excuse me, the building we were just in 76, this one's 77, and then over the years we've added on to it.
Wow.
Yeah. In addition to the electric motor test equipment, we also build control panels. This one has the components on it, but not the wire yet. From a kind of technician perspective, and again talking about the notion of a internship, these systems start out with drawings. This is a pool filter company, and component lists, physical layout. So that's the HMI, so the screen and the metering on the front of the system, the panel itself, internal layout of components, and then finally the wiring diagrams that go with it. There's coursework through Central Piedmont, and I don't know exactly what they refer to it as, but there's a kind of electrical engineering tech kind of associate's degree. Right. And like we were talking about before, what do you recommend for people as they're looking at college? There's some great associate's degrees that can become a starting point to get you into a job that gives you a really good look at what an industry or a career looks like. Then you can go back and finish your final 2 years at a 4-year college. But we for employees that have been here a year, we try to support and cover the cost of community college training and certifications associated to the work that we do.
Nice.
Yeah. If you look at the shelves as we walk by, these are repair jobs that we have taken in and quoted. So these are, a lot of electric motors and gearboxes and things that have been disassembled. We've quoted the repair and we're waiting for the approval to go ahead on them.
Wow, that's a lot of jobs.
Yeah. Yeah, there tend to be, on the repair side, about 200 active jobs
Wow.
at any given time. So there's a lot of demand for the work that we do. This is an electric motor test system. This is the power circuit side of the test system, meaning this is a Jenkins transformer that brings in whatever the building power is and then allows or provides outputs at all different voltages depending on what size motor you're going to be running. This system is going to a repair shop in downtown Los Angeles.
Wow, so it's really nationwide then.
Yeah, nationwide. We've got systems in Australia,
Wow.
Indonesia, Ghana, Oman, Canada, Mexico.
So really
around.
international thing.
It is, yeah. There are only a few companies in the world that build electric motor test systems.
Wow.
Jenkins being one of them. The large contactors that you see on either side are the things that the PLC software controls to select the power output. This is the operator console for the system, so the technician who's running the motor test runs it on a touchscreen software interface. In addition to the PLC program that we use to manage the control system and the C# or C++ user interface.
Wow, so a lot of coding as well.
Yeah, we also use LabVIEW. LabVIEW handles a lot of the data acquisition that the system does, so it can generate reports after a test is completed.
There's a lot of data science as well then that goes into
There
all
is,
of
yeah,
this.
there's a lot of data, a lot of database logic to make sure that at any given point, if a repair shop was to get that same motor back, they could put the job number in and pull up the test data from when it left their facility.
Wow.
This is the control system, so power control. And then on this side is the motor starting circuit and metering. So this is a soft starter where you pick a voltage and then this gradually ramps up the voltage out to the motor. This is a variable voltage supply for being able to run small AC motors or control the field on DC motors. If you look over here at this supply, this is a power motor test panel that my grandfather built in 1939.
Wow.
We're still using it as a power source when we test the large motor test systems. This is the power output to run whatever piece of equipment that you're testing. And then this is all data acquisition. So this is accelerometers, which measure vibration, RTDs and thermocouples, which measure temperature, and a tachometer, which measures the speed. And essentially what you're trying to do is look at the nameplate on the motor under test, and it has an input voltage, and it says at that voltage you should see a certain RPM. And obviously you want to make sure that nothing's vibrating, nothing's getting too hot when you run it. Actually, I'd say, Colin, stand over here. That way you can see the CNC equipment. So this is we started out in the repair shop with manual machining. This is a CNC machining cell, so computer numerically controlled machines. This is the part of the business where we build products that we also sell to other repair shops. So electric motor test systems, we're a repair company ourselves, And we got to the point where we needed to be able to test something, so we thought, why don't we build the system ourselves?
Right. The do-it-yourself mentality.
And then we can sell it to other repair companies. We know what it should do. We know what their experience is, so we should be able to build a system that works well for them. We also manufacture a lot of replacement parts. And in a lot of cases, it's obsoleted designs that the OEM or original equipment manufacturer has chosen not to make anymore. So it's kind of aftermarket parts that we sell to other repair shops. We've got a pattern library of about 4,000 designs for parts, and Jenkins.com is an e-commerce site where you can go and buy products online. From a technical perspective, again, these are CNC programmers and operators that work in this part of the business. We have a mechanical designer who we're putting through a mechanical engineering program at UNC Charlotte. So we'll have a mechanical engineer in this part of the business.
Wow.
As well. Yeah. Yeah, this is this part is a aluminum fan that goes into a mining application. Now this is straight out of the foundry, so it doesn't have any machining done to it yet, but it goes on a motor that has a fan like this on either end of it and moves air through it to ventilate out of a mining operation.